Hi everyone, welcome to part 4 of the Serpano Bring Up Assembly and Bring Up stream. Today we will focus on finishing up actually assembly of the board. There are 2 parts missing, or 3 parts missing, and that's the I2C potentiometer that's used to adjust the variable voltage. It's the current sensing, and then the battery charging circuit, which that's like the least interesting part, so we'll see where we go with that. Finally, Dave, it's like 1 minute. It's all good. But yeah, I think before we go get into it, let's give a few minutes for everyone to join in. Let me just get that microphone in here. There's a blind dog. I'll check that later. Hi Brian. Hi Johnny. Henrik. Thank you for thank you for your permission. So before we get into it, I can show off some stuff I've been working on recently. For that, I guess we will switch to this cam. And this is the overhead. There we go, very skewed. Wow, this lighting is really bad. My lavender doesn't look like lavender like it should. Hi Gerald. Hi Rotter. The Flexi friend seems to be working. That's great. Finally, you got those diodes. It was the magic element missing. Stuff? ESD, just get a balloon, rub it on your hair and zap it. But what I've been working on actually yesterday is I have this board here with that is not focusing. I have this board with the ESP32S2 with the new, well, it's not so new anymore, isn't chip, and just a slightly high resolution display. It's like 230 by 180, something like that. Looks quite nice. It's more than usual than you would expect from this size. And yesterday I ported it to Arduino, which I just had to add some pins. And then yeah, I was just playing around with the display. You can see here if it chose to focus, but it won't. Actually, I don't remember. Maybe I disabled autofocus on this camera because I didn't want to, because it kept adjusting itself. So maybe this is to be expected. And you might say this looks like a Adafruit feather, and it very clearly says here that it's not a feather, because you can see this is a feather and it is 1 row wider, and that's because I couldn't, well, I could probably fit the display in there, but not the module. It's just too wide, so that's a bit unfortunate. I will have to find a good name for this to make it clear that it's not a feather. Someone suggested brick because that's the opposite, but that doesn't have a good, connotation, so maybe let's not do that. What's happening in the chat? Hate cats. That is the wrong position. Cats are awesome. There's a video on ESD. Yeah, autofocus is bad. The colors are also really bad. Like this is lavender. This is not supposed to be bluish. Is the that's the wrong camera. The white balance is all off. Configure video. There we go. Now it's the white balance is a bit too much. Yeah, this is like the real color fish, except I'm very red. But I believe, yeah, no, the autofocus is on, so it should focus if I, there you go, not a feather, yeah. So here you can see the comparison. This is my IMX RT10 11 feather, which is still unreleased. But that one is actually next on the list to go on Tindy. I guess these two are, but I think this one is next. So I have a Tindy product that's incoming in like 2 weeks, I would say. I'm really finishing up some stuff, and then I will have a new product, and then next in line for production is gonna be this guy, and maybe both at the same time. It should be fine. NAF, is it like a E NAF? It goes back on white balance. That's unfortunate because now the color is quite nice. Hi Bleep Track. What are we? Are 10, I guess. Or no, we are 11. But yeah, I guess we can say that's enough. Usually we hit peak around 30 minutes in, because I guess people check their email, get their notifications and such. But yeah, don't have to wait that long. Let's see if it still works. Yeah, no magic smoke. The backlight is on, you can't really see it, but no magic smoke, so we claim that as a success. Enough is a slang for BitCraft. Okay, I have not heard that one. Promote MakerCast, but there's no link. There's no. Is there a MakerCast? It hasn't been announced. Hi, Amin. So yeah, since we are 12, I guess most of you are aware that every first Sunday of the month there's a MakerCast on different YouTube channels. It jumps around between the hosts, and there is of course one this month as well, and I will be on it. I'm not hosting. Brian is hosting, if I remember correctly, and then we have, who do we have? We have Dave, and we have Sion, I believe, and Dave will say who else. I don't remember right now. But yeah, mark your, what is the save the date. That's the word. That's the one. It's tomorrow at 9, I believe, p.m. Not tomorrow, sorry, Sunday. It's only Friday. That's good. Yes, Adam is on, and who am I missing? Brian is hosting. There's Dave, Sion, Adam, me. That's 5. I'm missing someone. Right, John Oxer. Yes, that's 6. That's all of them. Even though someone mentioned, yeah, okay, it's 10 p.m. my time, Central European, I believe, and then 9 p.m. English time, British time. Hi Morgan, you have made it. Yes. Right. There, this one. I have some printouts here. I don't know if I should go quickly through the schematics yet again. I do it every time, but if you're new, not a mod, I don't know. Can I trust you? Put in timeout or set as mod? These are hard decisions. There we go. So let's quickly, where's my pointer? My favorite pointer. Oh well, I guess I'll just point with a pen. Yeah, I don't know if I would trust Bitluni with modding. Every time he's in my chat, he's trolling. But let's quickly check this out. Now you can, it's really blue now. So yeah, the white balance is all kinds of screwed. Yeah, exactly. It's fine. Like you can definitely see the white of the chat compared to this bluish tint of the paper. But this looks good, so that's the most important part. So if you need a reminder or this is your first stream, then you should watch all the other streams later, just saying. But this board, it's a power supply that runs CircuitPython that you can connect, into a breadboard. You can adjust the voltage, you can toggle some pins, you can read some pins, you can show it on a display. There's 3 buttons. Use your imagination. It's limitless potential, you know. And the way it works, we have a SAMD51 that runs CircuitPython. It has a QSPI flash. There's a LCD here. There's a NeoPixel, which is still missing because there's a test point under it, so I don't want to put it just yet. And that's it on this page. Then there's 3 ways to power this board. You can power it from a LiPo, and there's also a charging circuit, so you can charge that LiPo. And it's not gonna take you far because I don't even know how much current can a LiPo provide, and it's 3.7 volts or 4.2, so yeah, we can boost it, but the efficiency of that won't be great. USB Type-C with power delivery, which still is to be tested really. But in theory, we could get like 90 watts out of this, which is scary. And there's a DC in, so you can have like, 9 volt, 12 volt, whatever. Then there's a fuse, there's a switch, like a toggle switch, a deadman, not a deadman switch really, but if it starts smoking, you want to press this and it will physically disconnect the power. And then we boost whatever we get here to 15 volts. And then right after we do that, we have a triple buck, which will lower the 15 volt to 3.3, which is used for all the chips, 5 volt, which is used for the charging, and then there's that adjustable voltage, which is adjustable via there's a feedback resistors here, and there's a I2C potentiometer here, so we can dynamically adjust the resistance. And there's current sensing for just the adjustable rail, so you can measure the current of whatever you have on your breadboard, and it doesn't include the MCU and all that, so should be cool. Oh, we are 19. That was a nice jump. Yeah, and it's also a Millennium Falcon for no reason, not on purpose, but you can, whatever. So I thought we could actually start with the current measurement, because the adjustable voltage works even without the potentiometer. It just works as a 0 ohm at that point. So, and there's also already a Adafruit library for the current sensing chip. So if we could get that working, then we could use that to actually verify the pot. So that would be hopefully useful. Snowspeeder, whatever you want. It can be, again, whatever you imagine it. Okay, let's see. face. And then we move this out of the way. We move the microscope in. There it is. This is not a big desk, but it's doing its best. And preheat the solder iron. That should do it. No hot air today, I think. We'll see. All right. We can move in this one. Yeah, this one's not very interesting, but oh, there it is. Okay. Right, and so that was the overview of the hardware. Then on the last stream, we actually soldered the MCU right here, and we got CircuitPython. We got UF2 bootloader on it. Then we got CircuitPython on it, and we tested the display and one of the buttons, which I flipped. Doesn't matter. It seemed to work. So good so far. So hopefully it's smooth sailing from now on. There we go. So this is actually why is this so low? Right, I was actually, this is really too much movement. I was using this without the ×2, no, the 0.5 lens, because I was doing something very, very, very close. So I had to move it down. Okay. Now we should be. Yeah, that should do it. Why is this so wobbly? That should do it. Anyway, it's just two components right now, so should be fine. And okay. There we go. What's in the chat? USS Arturo, Pew Pew, all good fun. Right, so let's start. This display is a bit in the way. I still haven't found a good way to place this microphone. What if I put it way up here? The springs are not great. Okay. Maybe. Or it falls on my hand. We'll see. That will be good content too. I should flex it. Flex it good. So Johnny was nice enough to offer sending me his camera adapter that should allow me to have a larger area visible in the camera. And because what I see in the view and the eyepieces is way larger area than through the camera, which is annoying because then I can see a part and it's off screen for you, which is not great. So hopefully that will help. So thank you, Johnny. Maybe for the next stream it's here. Fingers crossed. Right, so this is the chip we will be using for current measurement. It's INA2198. And then there's, I believe, A and B, and it's B that's like higher precision, but LCSC didn't have it stocked. Mouser has it, but I didn't have a Mouser like €50 order, so next time. For now, it should be fine. I just want to see if it works. So how was everyone's week? This was my first week after vacation, so it was a bit of a tough one. Everyone else is on vacation, so it was just me working with a client, so all the issues were on me. Not super fun. But how was your week? What are your plans for the weekend? Let me know. Except, of course, on Sunday, everybody will be watching MakerCast. Rainy vacation, but today in Malmö at least the weather has been pretty good. Like right now it's really sunny. Oh man, why is this not? Huh, that's a very stubborn one. I wonder if this is... Nah, that's fine. Is that a ground pad that was continuing to a second one? Yeah, that looks like a ground pad. Because this is... You can see it's bubbling up. Maybe you can't see. We will get to that one in a moment. I should flux it more. Where's the Shipu to tell me to flux? Flux, flux, flux. Oh, still waiting for the PCBs. If you order DHA, at least the nice thing is DHL still moves over the weekend, so that's quite nice. Just blob it. There we go. That's the way to do it. Why is this also so blue? Like, what is up with my color, with my white balance? Everything is really blue. Now this is in focus, and now this should be in focus also. Actually, for this one, I could do... I can see anything here. White balance. Wait, what? I didn't... Okay, just going to the menu fix the white balance. I didn't change it. It works. That was fine, yeah. Yeah, hi William. Don't think I said so right. Nice, the G series. I'm not familiar, I think, with the STM32G series. Is that... No, the L series is the low power. And then the W series is the wireless. I'm not sure what the G is. But I'm guessing it's an ARM0 as well, so it should... You should be able to program it in CMSysDAP or an ST-Link or one of those. Good enough. Man, you can tell I'm kind of tired from this whole week because this took forever to solder one chip. Oh, this is a big plane. Gonna need some thermal capacity there. I'll just put this to the side. 10-way switch. Is that like a dip switch? What? How is it a 10-way? That's nice. Just like 1 week of work sandwiched between. Okay, it's IM0 plus. Nice. So here we have the big current sensing resistor. I don't think you can tell how really big it is. It is big, and it's a 2512. It's 0.02 ohms, 1%, 2 watts, and it says try first, so I'm trying it first. Yeah, it's really satisfying when the solder wire, or yeah, the solder wick just takes in the solder. But it gets greedy, so you gotta keep it at bay. Wow. Quite big, quite blurry. Push switch with rotating numbers. Oh. I think we need a few more degrees here, or a thicker tip. Let's see. Hi, Matau. Okay, that should be good enough. So correct me if I'm wrong, but my understanding of how the current measurement works is the sensor. So the voltage from the back goes to the one side of the resistor, and then you actually use the other side of the resistor to power or all your whatever you want peripherals devices. And then the chip, the measurement chip, actually measures the voltage on both sides, and then based on the voltage drop on the resistor and knowing no, it doesn't know the voltage, it measures it. But yeah, somehow based on the drop over the resistor, it knows the current consumption. And since it knows the voltage, it can measure power also. And that's pretty much how it works. Okay, 30 minutes in, we have 2 things soldered. Yeah, and this is where the I2C pot will go, right here. But otherwise, I believe we have everything here. These are optional. Yeah. So let's switch here. So many things in the frame. So now we're gonna try something new, where I bring in my laptop, which I mean I did on the last stream, but just for a moment. But now I have it properly, and Right, let's see. Okay, that works. Cool. And I don't know, you can see the front, the top view of the laptop. That doesn't make sense. If we can do, we can't really. Where is the board? It's here. Connected. And you can see here I have a USB Type-C power measurement. Oh yeah, okay. Because the backlight was not on and it was showing 0. I was confused, but the power switch is up, which works as expected, so that's good. Okay, I don't think you can see much in this tiny window here, but there we go. Yeah, and then we found it. All the CircuitPython stuff is still there. That's great. Webcam on the microphone arm. Yeah, this is actually not a microphone arm. It's a IKEA lamp arm, and it's the same one I'm using also for the microphone. So it's super nice to just be able to adjust it. Except the springs seem to kind of wear over time, so it doesn't want to stay up anymore. But so good so far. It's a bit in my way. If I have a light here, which is a bit in the way. I don't know. I don't think you can read this. Right now it's 54 milliamps because there's some backlight action going on and the SAMD is going. No. Yeah. Actually, you know what? This will do. So, yeah, this is the chip. I'm not gonna, like, I already read some of the datasheet when I was designing it, the board. But since there's a library, let's just try the library and see where we get from there. But what we can do is actually see if the chip is visible on the I2C bus. Or actually import board. Let me know, is the font too small? Can you see? Can you see or can you not see? Because the problem is that the desktop is smaller than the full screen. All right. It's too small. We can fix that. Can fix that more. Yeah, let's say that's big enough. I'm guessing this is too small, but then we will zoom. So what did I run? Right, we lock it and then we scan it, and we have two devices. Great. So one of those is now I forgot, what was it? What was right, it's the USB power delivery, one of them, and the other one now is the current sensing. Right. And then you can see my touchpad has some problems, so I get this drift from time to time. I need to buy a new one and replace it. Is this the one or is it the other one? What was the address here? Right, this one has like really impressive feature for how many of these chips you can have on one board. Look at this. There's 16 ways you can set the address of this chip, which is like, yeah. Usually, sure, if you have 2 pins, you can have it high, 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 low, low, high, low, low. That's it. You have 4. But here, you can pull it to not only high, like low and high, but also the bus voltage and the SCL, SDA. It's pretty crazy. And I think I have the schematic here. I think I put it low, low, and I even put a comment. Right, it should be on 40 hex. And 40 hex is 64, so this is it. Cool. So what we will do is we will download this library. What are the requirements? I don't think we have the bus device, so we will need this one also. There we go. How big is this one? Nope. Big. Oh my god. This is not the first time I'm doing this, apparently. Number 6. This is the one, right? And then INA. Problem is, every time I do this, it's a new version, so you know, it makes sense to keep downloading it. Yeah, but if this touchpad has a drift, then it's not super useful. But this laptop is not at all. It's like 2 years old, so I don't think it's iSquares. It's a PS2. I guess we'll see. Right. So there's this one. All right, and then we also copy the example. And then, oh, that's a lot. Bus device, wasn't it? Circuit Python, bus device. It's possible I already did this, to be honest. Yeah, it's already there. Because I think I had to do it for the display driver. Right. So now, I think I still need to edit the address, because I don't think they use. Wait, that's not right. There. Ah, the default. Cool. So it should just work, which is never true. So to be honest, I'm not sure what numbers I'm expecting. I should measure. We'll do that in a moment. What is the actual... Ah, okay, so I'm still missing. I will measure it with a multimeter to compare. So we'll see. Yeah, so this is not the most exciting stream, I guess, downloading and copying files, but give it a moment. That was also not the first time. Hmm. That's not right. It should print something. I wonder if interesting. Let's just toggle everything right now. Excuse me. That's new. That's different. Not sure if different is better. Extra keyword. Could it be because I'm using I think a master branch or main branch of CircuitPython, and I think there's been some changes, so that might actually be it. So let's actually copy the new file I download, the version of the bus device. Oh. Otherwise we will have a quick look. There it is. Okay, yeah. 1.2, which I think is actually, yeah, 1.2-ish. Wow, that's... there's no load on it, so that explains it, kind of. Yeah, so the issue there was I'm using main, the upstream of CircuitPython, because I built my own, and there was some changes recently. I don't remember them exactly, but now I updated my library and that fixed it. Cool. I think 1.2 is correct. Let me verify. Let me put some load on it actually also then. Wow, there's a lot of cables. That will do it. Yep. Multimeter. I should not run the Swedish CircuitPython. I run everything I can in English. That's my preference. I don't like native language anything. Right. Now you can see nicely the value here. Yep, right. I need to move. So give me some ground. Give me some power. 0. That's not very good. Right, if only I was measuring DC and not AC, that would probably help. Yep, and then it was connect. Hi David. That is indeed almost done. Except now we lost it. I hope nothing shorted. Cool. You can see without any load, it's very jumpy, but it does seem too much, whatever we are seeing here ish. I think if we put some load on it, except, alright, it's a new multimeter, and this one doesn't have an off position because the off button. But what load can I put on it at 1.2 volts? I could put just a resistor, a through-hole resistor. That's funny. There was some way to calculate the current with a resistor and voltage. I guess we'll never know. Except I don't have any resistors. Because who has through-hole resistors, right? Let's see. I don't even have a through-hole diode, because I mean at 1.2 volts I could just connect it without a resistor. An IR diode. Oh, you're overestimating my setup here at home. Everything that's fun is at my hackerspace. I have a very, very limited supply of things here. I do have a... This I didn't consider. Yeah, exactly, a resistor would be nice, but I don't... Maybe I do. Just a moment. I know, right? Any wire is a resistor. Also, any wire is an antenna and a capacitor. So I have a resistor. It's a brown, black, black, black. No, brown, black, black. Gold, whatever. I don't really use through-hole resistors that much, so I don't have it memorized. But worst case, it burns, so that's fine, right? Whoop. Yeah, that's stabilized. Nope. I was gonna say that stabilized the voltage, but not really. But you can definitely see the current, except did I connect it the wrong way around because it's showing negative? It's definitely a possibility. Right, but that works anyway, so we can... Another headphone speakers. Yeah, so this seems to work. We can actually go for the pot, and then we can set it to some higher voltage, but still... do I not have anything? I didn't think of that. That's impressive. Over. Let me check my box of random things. Yeah, nothing for 1.2 volts, because if I use the pot and then get it to 5 volt, then I can or at 3.3 I just connect like a random board and do that. And I actually have a 5-volt DC load just for testing that I bought for this, so that will be easier. All right, let me switch to Mathèse. So let's go for the potentiometer. One hour in. Man, time flies. You no idea. This goes up. The setup is gonna take longer than soldering that one chip, but what can you do? I didn't want to solder both. I don't trust myself that much. Like, was Philip on Twitter? Like, I wish I had that confidence. He did a revision 1 of a board and ordered 100 boards. I'm sure it works, right? And I'm usually like, should I order 5 or 10? Like, I don't really want 10 boards. What if it's broke? Like, it's just a waste. So I usually go just for 5. Oh man, I should go even higher here. There you go. Yeah, that adapter will be definitely useful when it comes. Setting the temperature. There you go. And here we are. And we can switch here. And yes, this is the potentiometer. It's a, where is the number? There. CAT5171. And this is a 50K in 256 steps. So you just set which step you wanted on over I2C, and you get somewhere between 0 and 50K on, which is, I mean, it's so nice, so easy. Famous last words. Yeah, that's true. Sometimes, like, the economy of scale is crazy that you can sometimes for the same price get way more boards if you just panelize. Or, you know, you pay $1 more, and instead of 50 you suddenly get 300 of them because you just panelized. Because you use still 50, but panels and panels of 6, suddenly it's 300. Pin 1 is here. Trying to make sure it's in the flow. This is a bit on the edge of the microscope stand, which is not great. just gonna flip it around in the folder. There we go, stable. Then we flex it real good. That one never gets old. As you can see, this is just how I do it. I blob it and then I clean it a bit, because sometimes it's easier than trying to be gentle with a tip. Yep. That should do it. So this actually concludes all the components on this side. That's great. To be honest, it takes longer with these SOTs than with a QFN, because QFN you can drag solder. But it's also a bit my fault here, because I put the cap here. I put the cap way too close for comfort. Yeah, so that was it on this solder session. How is the microphone working out? Because I actually like this setup. It's not in my way. Yeah, you can see it in the frame. It's way here. It's kind of mouth height. It's pointing at my face. I think it should be pretty good. Oh, I know it's definitely good for me. And maybe it's actually good because it's not picking up stuff that's on the desk, like me making lots of noises. Sounds great. That's great. Just clean up here, you know, a clean desk is a desk that's clean. A touch low. I think, yeah, I heard that complaint before also, but it's at max, whatever I could do. Why wouldn't it be audible, Adam? Was it windy or something? Still works? Still works. Great. Zoom. Now the camera, this, you can't see the arm. It's perfectly in my way for the monitor where I see the chat. Yep. It didn't explode, so that's great. One day it will. Okay, we got it. An iPhone 11 to make a YouTube video. Yeah, I'm quite like I'm an Android guy, but you definitely can't badmouth the iPhone's cameras. Like when I see photos made by the iPhones, they're really good, and the cameras as well, and the videos. It's actually interesting because, as far as I know, iPhones use Sony cameras, or at least Sony sensors, which are the same sensors that Sony uses in their Xperia phones. but the photos that iPhones take are so much better because the software it's better, like the processing that they do, and that's just sad for Sony that Apple can just juice, no pun intended, get more juice out of those cameras. Now we should have 3 I2C devices. Board, are you ready? And the number should be it should be 5H, which I don't know off the top of my head why that is. It's, what is it, 64 plus 16, so that's 78? Okay, that's not right at all. I mean, it's there, but the address doesn't match what I was expecting. Oops, hey, where are you going? So the address was 44, which is 0010110. Oh man, now I'm confused. Which one was it? Oh, this is... Which address was the power delivery? That's too far. Right. Yeah, so this 44, that's the one. That is the one. And that's a 2C. That's a really strange. That's unfortunate. Yeah, I'm quite happy with the setup I have here because I have this confidence monitor here where I can see, like, I can see what OBS is showing. So, and then I have the chat. This is oh my god, what is it called? It's Anterg OS, which is Arch Linux based, and now it's discontinued. So yeah, it's a discontinued Arch distribution, but since it's Arch, it just keeps getting updated anyway, so it works. There was a new Arch distribution that I quite like. No, I don't remember. But I think it was part of the team that did this OS, just moved on. So yeah, Arch Life for me. The way I like it, which, yeah, you can see here, it looks, or I set it up a bit to look like Windows, because on my main desktop PC where I do design stuff, I have Windows, and I don't mind Windows. I grew up using Windows. But yeah, for dev, you need the Linux, and I just kind of made it look like Windows. I made it look, which I guess is blasphemy for some people. Right, so I'm not sure why the address is what it is, because it's it was not supposed to be, unless I'm mistaken. Right, wasn't, where's the calculator? 10110 and the next bit. Okay, so that matches. So I guess I did my math wrong. Yeah, I used to use Mint before this, but yeah, I agree that like Bare Arch is really bad because you have to do everything yourself, which some people love, but I like my systems to be like problem free. And this distribution is really nice, or like used to be really nice because yeah, it just works, and I just run updates every week or so. It keeps updating, nothing, it just works. And this is actually, so this is Cinnamon, the shell, which is the one from Mint. So it's Arch/Mint. Yeah, Manjaro, I think that's also Arch based, isn't it? Ubuntu is great. I mean, I use Ubuntu on my work laptop because it just works, and yeah, I can't complain. It's super like stable because it's Debian based, and then the updates, like they don't update very often, and I guess that's fine as long as everyone uses the same version. Then you're good. Like it's the same. It's this everyone at work. I mean, so yeah, I'm not big for wars like Linux or Linux Windows or Android iOS. Like if iOS works for you, go for it. I'm not a big fan of iPhones, but whatever works for you. I'm not gonna preach. Hi, Leszek. Yeah, that's Unity is yeah, special. And GNOME 3 is also I'm gonna pass on that. It's too tablet for me. Right, I should concentrate, or maybe I shouldn't, because maybe it's fine to just talk. Yeah, Kubuntu is great also. Like KDE, way before Mint, I used to use KDE, and like it's great. Whatever works for you, you go do that. So we agreed that the number is strange, but not unexpected considering this. So right. I had a quick look at this, and the way this works is super simple. When you read, you just read a byte, and that's the actual value, that's the step between 0 and 255. And if you want to write, you just write 2 bytes, and the first byte, you only really care about these 2 bits here. I'm not sure if you can, these 2 bits here, and this one is like a reset one, so if you set it high, it will reset the wiper, as they call it, I believe, to the middle, and that's actually the default value. Right, we should measure the voltage, because now the potentiometer is there. The reset will reset it to the middle, and there's a shutdown, which I believe just turns it off. But otherwise, you use the second byte to set the position. But we should actually try the... Oh, that's misspelled. Simple. Yeah, something is still funky. Something's funky. Wait a second. No. For a moment I thought, did I put pull-ups on the I2C bus? But I did. It has happened before that I forgot those. Okay, there you go. 2 volts. So yeah, something changed. I don't know if that's the expected value. I would have to do math. Don't want any of that. Fine. Because at if we set it to 0, if we set it to 0 ohm, which I believe is 255 in steps, we should get 12.1 volt. If we set it to 50k, which is 0 in the register value, we should get 1.65 volts. Now we're getting 2.48, which is an interesting number because that's it's a very round number. I don't want to do this math, so we just assume it's correct right now. So again, cool. Yeah. Okay, so we can so let's set it to a number, and then we can try to read the value, and the value should be, I guess, 128, because that's the middle and that's supposed to be the default value. So now I2C read from 2C into buffer. Luckily I have this open because but that's how it is here. Right, you know, I screwed it up because when I did this assignment I changed it to an int. There you go. And now it's still a, yeah. Right. 80, which is middle. That worked. There's a lot of OS chat here, I see. Did I start a war? Yeah, the Windows on like Windows running Linux. I don't remember what the WSL stands for, but it kind of works. Like I use Git Bash on Windows, and that's like the min GW, I believe, and that's been working fine. So I don't really need that one. But subsystem, that's the word, yes. But yeah, if they want to work on it, I mean, they mentioned Microsoft has announced they will include like the Linux kernel now in Windows, I guess just for this. So that's cool. Why do I have top chat here? I want live chat. There you go. And I want timestamps also. Okay. Yeah, I think it has a very limited use, because if you really want Linux and you're running Windows, you could run it in a virtual machine and then just share folders and such. And you can share USB drives also and whatever. So they're going in some direction. So what direction are we going in? We have now we have the number. We should set it to 0. That should give us 12 volts. Did I say that right? No, 255 should give us 12 volts. So first, let's measure what we have now. I know what the sensor said, but let's double check it before we wreck it. Right, you want that in the frame probably. There it is. Frame up. .5, which is 2.48. Good. So that checks out. So good so far. And then So we need the buffer to be 2 bytes. Yep. And then the first one, it should, I guess, be zeros, because we don't want to reset and we don't want to enter shutdown. But let's double check. So exactly, if RS is high, it would reset it to middle, which we don't want. And high on the shutdown causes the shutdown. So 0 there. And then for the value we wanted 255, I said, right? Yep. Oh. Cool, that works. Yep. So we do write to and then read from. We don't need to read. To C this buffer. No smoke. And I should just have a second buffer. Read buffer. It was byte array. So we can do the read just to confirm. Oh, my history doesn't go far enough. Great. So it should be 12 volt now, which we can test. All right, I already did this. So now we have access to this namespace here. What do we want? We want bus voltage. Oh, no. Damn, it stopped responding. Ah, shit. I know why. Because I should have unlocked the bus before I attempt this. Damn. So now we have to start all over, but we're smarter now. So we do bus, no. And as I say that, I screw up, so just to make sure it's still there. Cool. 1, then buffer is correct, and then we write it. Buffer. Buff to read buffer. Cool. Now we unlock it. There, and I think now it should work. Right. Okay, so 10.892. That's not 12, but it might be that just my math is totally off, or yeah, right. It's still, there's still some problems with the bug. So this might actually be correct, because I had to put higher value on the feedback to get 3.3, because I was getting like 3.2 and for 5 volt also. So if it's always less than expected, then that's to be expected, if that makes any sense. But if it matches here, then that's fine. That's all good. So let's see if it matches. It does. 9.1. Yeah. Who do we trust? I guess we trust the INA chip actually more. Hi, Deshipu. So the I2C lock and unlock thing, that's a CircuitPython thing. This is just to make sure that only one thing can talk on the bus at the same time. Hi, Dustin. It's okay, you can just type. Or you can talk if I won't hear you, but you can talk. Yeah, so that's good. So the numbers are not what I expected, but that's a problem with the bug. The sensor seems to work. The potentiometer seems to work, which is awesome. Now what? Now we should put some load on it. So now we have to, I should find a. I didn't have to do this. I keep forgetting. I'm so used to mine that I have to switch it to middle to turn it off that I will keep doing that. We should find a value that will give us like 5 volt, and then we can have some fun with the current measurement. Except the problem is right now this is all quite crappy code. So I'm thinking, should we just very, very quickly write a driver and to do that, there we go. We will copy most from the INA driver, so it shouldn't take that long. We just need this, and we need. Let me save that. All right. Also, let me do this for you. The split screen plugin is a bit buggy in Genie because it's a third-party plugin. So, like when I press Ctrl S for saving, it will actually save this one no matter like what I do here. As you can see, I'm pressing Ctrl S, and this is clearly an untitled file. Even saving like this. So I have to do this, and then I can save it. So okay, now we will get the colors, which is nice. And to make sure we're putting spaces. And then I believe, right, this was using the register library, wasn't it? Or maybe not. I don't think I used the register library just yet. Yeah, exactly. So we will skip all that and we will just do. Oh, it's been a moment since I wrote Python. Right. Hi, Paul. Couldn't chat. Now you can. Ooh. Nice. Getting nice numbers. So live coding isn't that bad. That's good to know. So what were we? Oh, that's a lot. Right. And then Like I say, I'm a bit rusty on... Yeah, exactly, there's already stuff for this. So we just want to read into buff. And then we return buff 1, 0. And then value... Was that how you do it? Oh yeah, this is... Or is it the setter? Oh my god. I forgot how to use properties. Sure. Just give me the good stuff. No. No. Setter, right. So the getter is the default and then use the setter. Okay, okay. Phew. We will skip the reset stuff for now, just for the sake of being fast. And just do right. But okay, this should work in theory. 5171. So board import 5171. Great. What did I screw up? Property. Okay. But it should be named like this, shouldn't it? Okay, just to double check, because I don't trust myself or anyone. 0. Now we should have a random value, to be honest. That's random. Yeah, and cool. So now we have a way simpler way to talk to the pot. That's great. And we already have a class for the for the sensor. So we should we could actually programmatically do that. Now I'm tempted to do that. Because I want to find the value that will give us 5 volt. And that should actually be pretty simple to do. So Yeah, exactly. We could create a very nice table very easily because we just set it, read it, print it, set it, whatever. My idea is later to actually have it as a constant loop where the user will say I want 5 volt, and it's not just that we will set the value, the pot value once based on the request and be happy with it, because I guess the more load you put on it, it will slowly drop. Since we have the current sensing and voltage sensing, it should be very easy to actually, oh, we see it's getting under 5, put it higher, put it lower. I mean, just pit it, It, right? It should just work. INA is right. So there's some nice values here that I want. Range is 16. I don't know what the default values are. So what's the bus voltage? Okay, I guess that's, and then shunt. Yeah, because there's no load on it. Yeah. So now if we go to 255, yeah, I guess let's just do that. Cat value is I, print yep. Okay, we are missing 255. Yeah, there's a table for you. Wait, what? We're getting some strangeness in these last values here. I wonder if we need a moment actually to stabilize after setting. You know what? Let's give it. At this point, I'm kind of just having fun with this. So that doesn't look correct either, does it? Huh. How much time does it need to stabilize? Exactly, there's no load. That's gonna do it. Stop. Yeah. No. That's a long time. Yeah, definitely it's a load. Yeah. Yeah, that's one way to do it. I would probably want it slightly smarter, so actually do math it out. So let's put a load on it. Let's see if it survives 10. What are we at now? 2. Okay, that should be fine. So let's try that again with a smaller. Right, that's the wrong order. Set it first, sleep on it, and then print it, which there. Still not quite interesting. Interesting. Ooh, magic smoke. Ooh. That resistor was not super happy with that, which I don't. Nice. Well, the smoke is gone. But it was just the resistor, don't worry. And cut. Yeah, you missed the magic smoke. I don't know if you could see it. It went kind of in front of the camera here. I can't really see it. It got a bit brown in the middle, you can see there, but it still had some kicky, like it could have gone longer. So what else can we do here? We can just okay, there's almost 3.3. It's not very linear, is it? Not at all. Wait, how does that work? Wow, that's like this scale here is not great. That might need some adjustments. All the resistors. Hey, Michael. Oh, did you, Bleeptrack, did you tweet about my stream? Did anyone tweet my... Ah, thank you. Oh, 24 of us here. Nice. Just in time for the magic smoke. Right. So the scale here is really bad right now. There is no load on it, which that is true. Where are you going? Where is the cursor going? Yeah, let's fix that. Ah. There we go. So now we have a 5 volts. I can, where did I, how do I, there it is. I think I showed this on a previous stream, or maybe I didn't. Stop bouncing around. Perfect. So I have this, I think I showed this. I have this DC load here, which is just a giant MOSFET with a giant heat sink and a fan. And what it does is you can adjust how much current it should sink, which should be nice for testing this. Except there's like, Or actually, I thought there was a external connector, but there isn't. Yeah, but it shouldn't be that much of a problem. Yeah, the I2C resistor is part of the divider, and that's how I can control the voltage, which, as you can see right now, is not great, but that is the plan. Hi, Timon. Nice, we have a nice crew going. So I'm gonna try to connect this guy, and we can see if we burn something. Is that a 25 turn pot? I think it's at its limit. So what is the easiest way to connect this to that? I think, you know what, at this point actually we can connect this into a breadboard, because all the bottom components are done and it's not like you can't access them anyway. So the only problem is that switching the context into soldering is not zero work. How to do, what to do, how to do. I don't think I have a USB cable where I could connect and get wires out. No. There's no easy access here. I can connect, I can solder there, but that's a bit annoying. Or is actually, like, you can see here if it focuses. Hello. Focus. Focus. Well, if it did focus, you could see that there is a USB minus and plus here, which makes me think it's data pins, but when I look on this side, it doesn't seem like the data pins are connected at all. So I think these test pads might actually just be plus and minus here. And we can test that theory with a bit of a continuity test. I'm not a big fan of this multimeter sound. It's not great. So let's try. It's annoying that it's on the other side, but we can do that. What the hell? Nothing is connected? Nothing is connected to nothing? Or there's just like to dig into there. So the minus is connected to pin number 4, which is ground, and then if the plus is connected, yeah. Okay, cool. So these that don't want to focus, get in there. Ooh. So these are actually the plus and minus in the connector. So that will work. So we do have to change to the solder context. Face. Hello. So let's switch to the soldering, and then we can solder the breadboard pins, and we can solder some wires to that DC load. Ah shit, I disconnected. I lost my precious 5-volt value for the pot. It's there in history. But And yeah, we still have the battery charging stuff to solder, but that's boring. I mean, that would be just me soldering for like 30 minutes with very little payoff. Like, it's a battery, it can charge. I don't think that's exciting. Okay. That was, I had enough foresight to prepare a breadboard that's ready to solder. I just connect it here and then can solder it. So that should go pretty fast. Pretty fast. Yes, exactly. I should get like a USB connector to wires, which I believe I have at our hackerspace, but not here. So I'll be honest, I could just solder the 4 headers that are needed for the power, but just a bit of hubris. I want to see the pin headers also connected. I want to see this thing with all the headers, because I think it will look pretty cool. Man, it's so dark. Go away. That needed longer than I expected to solidify. Now that's a good solder right there. So you can't really see because I have this kind of nice silk, these thick silk lines, but under them, I believe it's on the other side, I have the same thickness lines. Oh no, copper lines. So hopefully they are beefy enough to provide, you know, whatever much power you need for your breadboard. And it's also a 4-layer board, so soldering to 4 layers is not always super fun, as you can see here. I'm gonna move the display. I don't want to burn that guy. Yeah, so like I mentioned at the beginning, and you also can see here, there's a 4 times buck in here, and one of them is for the adjustable but voltage, but there's also always on, or actually not the always there. No, there's a 3.3 volt that's always there, but there's also a 5 volt. Oh no, actually 5 volt is also always there, because it's the charging circuit that you can disable, because you don't want to charge the battery with the battery. But you can see here on the header, you also have access to a 3.3 and 5, so you don't have to waste the adjustable rail just to get one of those voltages. So if you need like a 12 volt for your motors or like a 1.2 for something, you're good to go. If you need 1.2 for your FPGA on your breadboard, easy peasy. Right, and then the other side. What time are we at? It's 10. Okay, so we're 2 hours in. I think we've made pretty good progress. Both chips worked as expected. Like the voltage level, as I said, is not it's unexpectedly expected because the math probably or the math doesn't check out, but I did change some components without adjusting the math, so it's expected. There you go. And then I haven't mentioned this, but this pinout here, this is actually the same pinout that's in feather boards. You can see a feather here. Actually, it's this way. So you can see like 13, 12. If I move it more in. Yeah. So the idea behind that was that you can that you could use the like Adafruit shields, aka feather wings. You could just plug them in. But I got some feedback on that on Twitter, and the problem is, well, one is that you can see everything is shifted, so they would have to connect like this into the screen, so that won't work. And many of the feather wings also expect the 3 volt or the power rail and the reset here, which is not there. So for the next revision, I will probably flip everything 180 and make it slightly longer. So then it will be exactly like a feather, just this way. So then when you have a feather wing, you just connect it like this, and you're good to go. You can get it. You can use it with your with CircuitPython and the display. So that should be nice. And yeah, I'm not. I haven't decided yet if the SAMD51 is the final chip I will use, because I mean, with such a nice display and like ADC here and so on, it would be nice to have some graphing possibility and maybe even like a like a logic analyzer, stuff like that. But that obviously, if you want to draw this many pixels and measure and all that, it will require cycles, and it's CircuitPython, which is, it likes cycles. So it might be too slow. The 120 megahertz microcontroller might be too slow for what I'm thinking. So it's possible I will go with IMX RT, which is like 600 megahertz, 1 meg of RAM. It's a beast. And it's only like $1 more than this chip. It's crazy. So yeah, nothing is set in stone just yet. But yeah, look, now it's it's flappy board, but it's set in there. Awesome. And then yep. I don't really know why I'm really using the microscope for this. I mean, this is so huge. But I guess it makes sense for you because you can actually see what I'm doing. So it's not just my face or the overview. No gatekeeping, Johnny. But it is, yeah, that's a thing I've considered, and I talked about this at here on one of the streams. That one possibility would be to have Zephyr running CircuitPython, because I definitely want CircuitPython running, because it's so easy to just write random crap on it. But if I can have Zephyr running under, then I can just have a task, separate task that will actually draw whatever I want or measure whatever I want. And that's gonna go at the speed of C. And then Python will just be on the side. So that is an option. Because I could do that also in pure C CircuitPython, just make a custom C module and stuff like that. But still, C CircuitPython is not great with threading, and it's pretty much just a single thread. So if someone was running a CircuitPython while loop, even just while true, then nothing else would really be executed for the other code, unless I accounted for that and had like interrupt stuff and so on. So Zephyr, and there is already a experimental port CircuitPython for Zephyr, so I have to look into that. Yeah, exactly. Like Deshipu says, I could write a C module and have a background task, but it's not as clean as like Zephyr with its real tasks and proper management. It's at least something. I mean, it sounds like technically challenging, which is always fun. Like the boring solution is boring, so might just check it just to see. What is even here? Let's see. There's a big ass MOSFET. There's a resistor here. There's something there. 358. I'm not sure actually what it is. I never really looked into how these work. Okay, so I guess we want a cable now, and we want a connect on a plug. Good. Now I have two cables. Should get a cable stripper here. Be nice to have. Not as easy to do it with just cutters. You have to be delicate not to cut. Yeah, definitely boring solutions work, but they're boring. Yeah, that's true. An op-amp would make sense here. So the buck that I'm using for the adjustable claims to be able to output 3 amps on that rail. So I guess we should be fairly safe, because I'm not sure which way this pot actually, like, if I reach the end, is it now at minimum current consumption or at maximum? Will I just kill my power source, power supply, if I do that? I could actually test it first with my bench power supply. That's actually should be good. This guy went to sleep. And this tip is not the greatest for this. Yeah. I want to make sure we have good connection here. It's somewhat important. I don't know. Does anyone know what's the rating of these jumper wires? When do they start melting? I have them. I have seen these wires melt when they were driving like a strip of LEDs that was like a few hundred LEDs. The WS ones. So it's not unheard of. But I think we won't be going that many amps on them. Cool. Ooh, got a bit warm. Yeah, so what we will actually try to do first is try with my power supply. Use them as fuses, yeah. Okay, 5 volt, and I should have some. There's one cable. Come on. And there's the other. There we go. I can't really see the value there. And I set it to 5 volts. And there's the other cable. This wire, this is like, you know, the most standard just jumper wire that I cut off 1/2. So I don't know what's the AWG of that. Externally it's 1.2 millimeters. Internally it's less. I'm not sure. What on this guy? 2 amps. That should do it. Double check. Minus is minus. Cool. Okay, so it was 0, 0, 0, 0, 0. Now as I move it slightly, 200 milliamps, 300, 400. The LED here is on 500 milliamps, 600. So let's try, I don't know, 250 as a start. That's high, pretty high anyway. Is it? A bit warm. Not warm enough to start the fan. I guess the fan, I wonder if, I mean, the op amp is that, I'm just thinking aloud now, is that part of the circuitry that detects when the fan should go on. So when it reaches some power threshold, then it enables the fan. Okay, so 250 milliamps. We have calibrated it now. Sorry that you couldn't see all of it. Back to laptop time. Still works. Mm-hmm. Seems to be the problem. No problem. Is this breadboard shorted or something? Ah, it actually seems to be. Because when I plug it in, the device dies. Huh. A second one. Yeah, I don't see why. Any other reason? Yeah, it's this breadboard actually, huh? Because this one doesn't explode it. Point 1 can do 1.5 amps. All right. Cool. So now 231 was the value for getting 5 volts. I don't think I can get much more because I still don't use the power delivery chip, and I think by default it can only source 0.5 amp 500 milliamps. I don't think I can source more than under 500 milliamps because there's obviously some efficiency drops on the way. So I don't want to burn my laptop also. What power supply I'm using? You should check out one of my previous streams when I did unboxing. I believe there's even a link to the power supply in the description of that stream. But it's one of those cheap ones from Amazon actually. Like a 30 volt, 10 amps, just one single output, voltage and current dials. It works. I use it very rarely, but you need something. Uh, 219. Nope. Wow, that's a huge swing. Huh. I wonder if I should put some load there so it's, because this is not reliable at all. If huh. Anyway, now what? Let's do like this. Or even better, let's do like this. Let's just put it in a file, and that will be easier. That's a 5 volt, and then we can do this. True, if I can spell. Okay, there we go. And we can have a constant rolling, just print. Import power. Oh no, what? Oh. Right. Cool. So, can I fit this all in one frame? That should be fine. I don't think you can see on this meter, which is the type C meter that powers this board. It's showing right now 43 milliamps. We have it set to 5-ish volts. There's like 0 current consumption happening. I'm gonna connect this guy, and we see what happens. Yeah, so wow, is it really that bad? So definitely the voltage is constant now because we have like a proper load. And I'm not sure, maybe I need to calibrate the sensor for my resistor. Actually, that's why the current is wrong. We will look into that in a moment. But now that we have a stable load, we can find where we actually get like a proper 5 volts. If we do like this. Did I just corrupt my... Yeah. I might have corrupted the internal flash, which wouldn't be the first time I did that. Yep. Not the first time this happened. It lost its label. Right, I can't, because the label is lost, then it won't see any of these files. Yeah, I'm not sure how that happens. I think if I save a file, it starts writing that file to Flash, and if I reset it too early, it will do it midway. It will reset while writing, and it will get corrupted. What we can quickly do, I have so many backups on backups. Yeah, that makes no sense. Right, so now I have these files, which I'm not sure if they're... See, there's the corruption. Yeah, oh, I'm pointing at the screen, but... Yeah, impatience. See, there's a calibration here that I think I will have to do. But we can fix this. We have the technology. Storage. Yeah. So this will reformat the external QSPI flash, and we should be good. Yeah. So now we have a fresh system, and we should be fine. But I guess I shouldn't copy these files that I copied now, because some of them will be corrupted. So, all right, that's an empty one. The power, so that one is fine, and this one, and that's the two that I created, so I need to copy these. But the rest, let's just copy from the original. Oh, wait, let's go back. We want power. We do want power, and okay, and then the rest we just copy from here. Yeah, but who has the time to unmount? But this wasn't this was a soft reset, I thought, at least, because I just did Control D to do a soft reset, and that still did bad things. But that hasn't happened in quite a long time, so that's quite interesting. Adafruit display, no, Circuit Python display. Oh, I guess maybe that was from the desktop. I don't really need this right now, but since it was there. Register. What else is there? I guess we don't need a simple test anymore. The ST is... And that should be it. $64, man. Not sure what that's a reference to. Wow, so you can see the first reading was actually, the voltage didn't adjust yet. See, it got corrupted again. I didn't even... Are you serious? That doesn't even make sense. What the fuck? Yeah. Sec time. I don't have... you can't send money on my chip, on my stream. I don't have enough view hours. Yeah, exactly. I have like 700 view hours, and you need 4,000, I think, to be able to monetize. I'm 2.5 hours into this stream, so you know, we should get some hours from this. Yeah, so it could be if this guy is connected, maybe it's dipping the voltage of the flash. That's really strange. Let's see if that helps. The drive is not totally dead yet. Yeah. Right, 1K subs, but that's I'm on my way, I guess, to that, so that's okay-ish. I think 1K subs will come earlier than the 4K hours. Yeah, so the 4.9, that's pretty okay. It's interesting, it didn't, like my power design is good enough that the circuit didn't reset when I put all this load on it. But it's also interesting the amount of inefficiency, it seems, that we're getting, because this load is, I set it to like 250 milliamps, but you probably can't see on this one, this whole board is now taking 445 milliamps. So it's 200 more milliamps than this one. So I think boosting it to 15 and then bucking it down to 5, it's wasting a lot of power. Anyway, it's still strange that the current is wrong, but there are some calibration values here. Exactly 16 volt. What is the default? We still don't set. Right, I should copy more from the example. It was setting resolution and stuff like that. So maybe now we are like high resolution, but we can only measure to very low current. And 250 is not that high, but it's maybe more than we know. So these are the lines I want. Range to 6. So I guess that doesn't really set it to. Range 16 volt. It could be also 32. Right, and 32 is max. Yeah, so we lose, I guess, some resolution if we go to 32. And this should never go above 12-ish. So 16 should be fine. Right, so there's the default. I don't know if you can see that. So default is 32 volt max and 2 amps. But that should still give us some reading. Yeah, right, these calculations, 0, 0, 2. There we go. So I should calibrate to this, because this is the resistor I'm using. And then we get 16 volts, 5 amps. Yeah, so I think this was my thinking. When I designed this, I should have put a note for that. I save, I give it a moment. I even sync. Something's unstable. Oh yeah, okay, that's fair. I didn't add these imports. It's not pretty, but it doesn't have to be. Ah. Yeah, is that how it works? You just put a cash bag emoji and that works. Where does the 20 SEK show up? But I thank you for your, for the intent. Okay. For the intention, I guess that's the word. There you go. We had to calibrate. So 275. So definitely, I think I flipped the connection on the resistor because we're getting negative current, which is fine. We're getting 274 milliamps, but we're also not, it's not 5 volts on the dot. To my PayPal, yeah. I do have a coffee thing where you can tip me. But yeah. I wonder, yeah, if that small error of, well, 25 milliamps, that's not a small error. If we adjusted the voltage to be 5 on the dot, like it was on the power supply there, if it would, we would get closer to 250, I think. The math checks out. So, do we have power? Power. Exactly, we should print power. Raw power! It's set in watts, right? So I guess this should work. How precise is my voltage source? It's all crap right now, because Yeah, I use different inductors than I did when I did the math for the resistors. So as you can see, like when I set it to 12 volt, I get like, excuse me, sleepy time. When it should be 12, but I get like 10.9 because it's just all out of whack. So I don't trust any of these values right now. That's why I double check them with the multimeter, which I should do. And I pre-checked it with the power source because those I trust more than my own crap. Oh, I don't think you saw, but the fan on the DC load like spun for a moment. Ooh, the heatsink is a bit warm. Hope my desk doesn't catch fire. I mean, it's only 250 milliamps. It's not that much. Oh, so now the fan is on, and now it's off again. And I don't think you can see any of that. Even if I do like this, it's like 2 pixels for you. I know, right? It's like, it's not super warm, but if I hold it too long, it starts to burn. Nah, I can hold it. So, yeah, I can hold it and not scream. I mean, this is quality IKEA wood. It's not gonna catch fire, right? I guess it's PWMing the fan, so it's like a bit. But I want to see that power. Yeah, I do have a cork. Obviously not here, but this is fine. I don't think. Yeah. If I can hold it in my hand, it's not gonna catch fire. Is it? I don't know. I never tried to set it on fire. Oh, now it's on. And now it's off. I'm reminded of the scene from The Simpsons when it was... What was it? Like... I don't remember the text exactly, but it was a joke. It was Dr. Nick about fire extinguishers, right? One was non-flammable and the other was flammable, and it meant the same. I ruined the joke. Where's Brian? He knows all of the Simpsons. Yeah, exactly. It's Swedish design and then it's produced in Poland. Hi, Simon. Yeah, I will probably go like 30 minutes more or something like that. Just testing a bit more. I don't think we will solder the battery stuff today, and like I said, not sure if I will do that on the stream. I might, because it's not exciting, but we can still hang out, and that's fun. And I can get those hours, those streaming hours. Yeah, these are empty inside. It's actually quite fun. If you open the IKEA lac table, those square ones, cheap ones. Inside they have this cool cardboard honey pattern, honeycomb pattern. It's quite cool. And tons of glue. So show me the power. Save it. Yeah, right. Inflammable means flammable. It was like one of the earlier seasons. I don't know. I would say like somewhere between 5 and 10. At one point in my life, I did binge all of them from start to like, I don't know, season 25 or something like that. Okay, so I saved the file. I gave it like a minute. Do you think it's still corrupted? What? Some things, yeah. It must be this bastard here. Which is not great. Line 30. Okay, that I can. Yeah, that's on me. Yeah, that's not great. That is not great. There we go. Yeah. So we have 1.35 watts. So I guess the watts are not negative. What if it generated power? That would be something. Yeah, isn't there a YouTube clip of every possible scene from The Simpsons? I would guess. Yeah, I actually, regarding the black text on white, I'm not a big fan of dark mode, which is blasphemy for some. Like on my phone, in the apps, as you can see in my editor, it's only here the terminal, because terminal being black and white, so will be strange. But somehow, like when on my phone, when I enable dark mode, I find it harder to read white text on dark background. It's easier for my eyes, for whatever reason, to read black and white. So I try to avoid any dark mode stuff. But in the terminal, it somehow works. So I'm sorry, Paul, that you prefer the other way around. It's pretty warm, but still not terrible. I really want to increase the current so I could see what would happen on the laptop side. Would it just clip out on 500 milliamps? Because I didn't negotiate anymore. And I don't think the power delivery does anything on its own. You can see me increasing. It's going very, very slow. It went from 278 milliamps now to 282. If I turn it ever so slightly, I can also see the... Oh, now the fan is on. I can also see the increase here, what it's taking from the laptop. So it's 280, no, 480, 490. So we're... Interesting. So now it's 550. So it's not, it doesn't stop at half an amp. So maybe it's by default 5 volt 3 amps, and that would be really useful actually. Because now I can see on the laptop it's 800 milliamps, and you can see here it's almost half an amp. Just getting I know exactly. I mean, the board itself is powered from my laptop, so I'm a bit hesitant. But it's over it's over Type-C, so if it needs, it could negotiate more. Yeah. So now it's 1 amp from my laptop, but it's only half an amp here. So we have 50% efficiency. Holy crap, that's really bad. That's really bad. I'm a bit worried going higher, so let's leave it at this. So now there's 3 watts getting drained here. Let's remove that. Yeah, so when I remove the load, now it's only 55 milliamps being drained, being sourced from my laptop. And when it's on, was slightly over an amp, but it's only taking... I don't know if I can trust the measurements here. Yeah, it's even worse than it's just a buck. It's a boost and then a buck. And that's the problem. I mean, you have double efficiency issues. Exactly. Yeah. Again, I might redesign this because right now the buck is needed because the battery is there, so you can still power it from the 4 volts from the battery. And I would like to leave, I would like to keep that because it would be cool to have this as a portable. You know, you write some code, then you just plug the battery and you take it wherever you want, and you have this functionality. I'm just checking. It's not so warm. It got a bit warm, but could be worse. So I don't know what I could do to remove that battery or to remove the need for the boost. Because if it was only power delivery, I could just say, give me 20 volts and we're good. Put that into the buck, into the buck, and we're good. But I also want the DC. It's a prototype. It's not the final product. So we're learning stuff, you know. I'm trying at least to learn stuff. What was the next thing I wanted? Right, I wanted to increase one more step here. Because I wanted to get as close to 5 volt as possible. Wow, that's really close actually, 5.0. Oops, I pressed something. Yeah, so that's another, yeah. So it's a, Yeah, I need to think about that, because if a big load is connected, then there seems to be some instability with the flash. I would have to measure the voltages there, because maybe it drops, it can't keep up or something. There is an enable pin for each buck, so I could make it when you reset the micro Python, it will disable the adjustable voltage. That should help. Right now it's always on. But yeah, as you can see, it crapped out again. Oh, where are all the other files? Oh crap. Yeah, they went bye-bye. So I want to update all the files in this folder. So I know this folder has all the files proper, and that way I can just copy everything that's in here. I don't need that one. Display text. Do they have Tony's chocolonely? How do these look? Yeah, I think I've seen these. I don't think I ever had one, but I think I've seen these in the supermarket. Okay, so I think that's all the files. And let's sync. Okay. So one more thing that I wanted to try is, so now we get 573 2 or 3 milliamps at 5 volts, and I want to connect the load back to my power supply and see if we get the exact same value. Although I'm not sure how much you can try the current in the power supply, like the current indicator. Yeah, because it's only 2 digits also, so I get 0.54. But 54 is not 57, so... So, not sure if I can trust that. And I don't really have any other nice current consumption. Actually, I could do it. Yep, with the multimeter. So let's see. Ground to ground. One side of the multimeter. So I will put the multimeter in line here so we can see if that's any. Oh. Oh. Well, that doesn't make any sense. It's 1 amp, but then the power supply says 500 milli. Huh. Oh, it's a Scott from Adafruit is streaming soon. Then maybe it is time for me to finish up. It's been it's gonna be 3 hours soon. I think that's a good point. And I'm not sure what else we can really do today. So we assembled the pot and the current measurement. Both seem to work, more or less. There's still some stuff to figure out. I'm not liking that the flash gets sad when there's a load connected, because that might be really sucky to fix. Yeah. All right, there's one more thing. After last stream, I don't remember what it was, I finished up the pin table here. Exactly, I think we made pretty good progress. No, that's not right. Right. So what I did after last stream is I set all the pins here. So now, and I built this, but I haven't flashed it yet. So if I double tap it to reset, I should have the UF2, yeah. So then I can have all the pins in CircuitPython, because right now we can actually check. Right, reset. I think it's a very limited subset we have right now. Board. Or I already did it. I guess I did it. It's been a while. It's been like, what, 2 weeks? Anyway, so I have all the pins now, which is nice. Alright, I don't have this NeoPixel soldered, so that's unfortunate. But some of these well, charge enable will work, but the power good and the back is reset. This I had to disconnect because there was issues with the bug that I still have to debug as well. So there's quite a lot actually in this board that's unknown. It's okay, David. I'm sure Stargate is better than this random stream. And you can VOD this stream later on YouTube. Right. Yes, I'm just stalling, trying to remember what else and what, because I would consider the bring up done at this point. Like I said many times, there's the battery stuff, but that I did the same. I did this circuit for the charging so many times on different boards, on different feathers, that that's verified. That shouldn't work. That should work, no problem. So we are verified now. It's more fixing stuff that's broken. I will have to take all that I got here, make a revision 2, and then I guess we can go from there. I think for revision 2 I will just solder or just reflow it in an oven because it takes a lot of time to solder this. And power stands? No, I'm just chilling. I'm like a gamma male, not alpha, not beta. I'm just I have no power stances, you know. But yeah, I guess that's the plan. Take the learnings from this. I can experiment a bit more with the inductors that I have, because the values are really unexpected. Yeah, so yes, we will close up. You can go watch Scott's stream at, I guess, youtube.com/Adafruit. Yeah, so thank you for watching. Remember to follow me on Twitter if you're not. There's a link in the description. There's a link for Hackaday.io site for this project where I put updates, so make sure to follow that. There's some affiliate links in the description if you want to click them and buy stuff or not. That would be cool. And yeah, thanks for watching. I'll see you around. Now I have to find a button to click. There it is. Yeah, bye bye. Whoop, wrong button. Bye.